In this video, we are going to prove a theorem which states that the angle subtended by an arc of a circle at the center is double the angle subtended by it at any point on the remaining part of the circle. So this is the theorem. That means central angle is double the inscribed angle. That is in short. To tell you in one small as a formula, central angle is double the inscribed angle. That's what you're going to prove it. So this is the theorem. First we write the statement of the theorem. Angle subtended by an arc of a circle at the center is double the angle subtended by it at any point on the remaining part of the circle. Okay. So first let us draw the figure. This is a circle. This is the minor arc. Okay. A smaller part of the circle, that is minor arc. Let us name it as PQ. Okay. This is the center of the circle. Let us join PO and PQ. OP. OQ. So OP, OQ. Okay. Let us take a point R somewhere here. Join P to R and Q to R. P to R, Q to R. Okay. Now we have joined this. Now through R and O, let us draw a line. Let us name this as M. Okay. Once this is, so here we get a triangle and here also we get another triangle. Let's, instead of naming, using three letters to name each angle, I'm just using numbers to make things convenient and easy to understand. Okay. So let us name this as number 1, angle 1. Let this be angle 2. And let this be angle 3. This is 4. This is 5. This angle is 5. That means angle OQR is 5. Similarly here, MOQ is 6. Clear? So we are taken a small case, that is when the arc is a minor arc and we are trying to create one central angle and one inscribed angle. Can, instead of considering an arc, you can consider a chord also. So you can join the PQ also. It could be taken as a chord also. So central angle made by the chord or central angle made by the arc. Both are the same. Okay. So it's applicable for both chord and arc. So this is the case 1, first case, when the arc was a minor arc. Okay. We can take the second case when the arc is a semicircle. Now again we're drawing the figure. This is a circle. This is a arc which is half the circle, which is semicircle, and we name it as same PQ. I'm using the same letters and same thing so that proof is same and understanding is also same. So that's why I'm using same number, same letters and same orderly also doing it. Now let us join PQ. This is the center of the circle. Join PQ. Then take a point R. Join PR. Join QR. Okay. Through R and O, let us draw a line and name this point as M. So MR is a line passing through the point R and the center of the circle. Again we name this angle, angle 1, angle 2, angle 3, angle 4, angle 5, angle 6. Clear? Same order. Numbering is in the same order so that when you're writing the proof also, you have to simply rewrite the whole proof what you're doing here. Third case, when the case is a major arc, minor arc, semicircle and major arc. Now the arc becomes still bigger. So again we draw the figure. Arc. See, it's a major arc. PQ is an arc. Now it's a bigger arc. It's a major arc. Okay. Now So this is big arc, more than half the circle. This is the center of the circle. Join OP, OQ. So here this angle is a reflex angle actually. It is more than half, so it's not a small angle, it's not an acute angle. So an angle which is more than 180 degrees, we call it as a reflex angle. So here this particular angle is a reflex angle. Clear? So this angle reflex angle actually. Okay. Now let us take a point R again, same way. Join PR, join QR. So through Q and R, you can join this PQ also, chord. So the chord is here. Now we'll join this to name this as M. Again, number this angle 1, 2, 3, 4, 5, 6. Okay. So when you are proving this theorem, first you will have to draw all the three figures. After having drawn the figures, then you write. So this should be the order in which you are writing the proof of the theorem. So first they expect you to write the statement because marks is allotted for the statement also. Then the figures, then you write what is given. What is given? An arc PQ of a circle with center O and radius R and a point R on the remaining part of the circle. An arc is given, okay, with a circle of center O and radius R, and there is a point R on the remaining part of the circle. The arc is this side, the remaining part is this side. So this is on the remaining part. This is what is given. So on the remaining part of the circle, the point R is located. Now, what you have to prove here? I have to prove angle POQ, that is this angle, that is 3 plus 6, is equal to angle PRQ. Okay. In all three cases, it is the same case. So construction, in order to prove this, we have to do some construction, which we have already done it. So I just write down what is the construction we have done. We have joined RO and produce it to a point M outside the circle. So we have joined this and produced it to a point M, which is outside the circle. This is the construction part, which you have done while drawing the figure itself. Now, next part of it. Now let's go take the first case. Since I have already drawn the figure, now I am not going to draw the figure in details. I'll directly draw the figure here. So here, what the first case, what was it? When PQ is a minor arc as shown in the figure. Now I am going to draw the figure completely, directly the figure. This is a minor arc. This was the first figure which we have drawn. Exactly the same thing is copied and shown, so that now it becomes easy for you to see and understand what it is. Now, we know that an exterior angle of a triangle is equal to the sum of the interior opposite angles. Now, if you take this triangle, this is an angle outside this particular triangle, that is POR. And triangle POR, 3 is an exterior angle. So we write that in triangle POR, angle POM is the exterior angle, that is angle 3. POM is an exterior angle to triangle POR. You can very well see this angle is outside the triangle. So when this is an outside angle, an exterior angle is equal to sum of opposite interior angle. So angle 3 is equal to angle 1 plus angle 2. So angle 3 is equal to angle 1 plus angle 2. But OR and OP are both the radius of the same circle. And that means in this triangle, these two sides are equal. If sides are equal, then the angle opposite them must also be equal. So let us write that. But OP is equal to OR is equal to radius of the same circle. So angle opposite equal sides are equal. That means angle 1 is equal to angle 2. So these two angles are equal. So I can replace 2 with 1 only. So I can write angle 3 is equal to angle 1 plus angle 1. Angle 1 plus angle 1 is 2 angle 1. So angle 3 is equal to 2 angle 1. Let us take this as the first condition. Sorry. Okay. This is the first condition. Now we do the same thing with this side triangle. R, O, Q. Okay. If you take this particular triangle, here 6 is the outside angle outside this particular triangle. Clear? So we do write it here. In triangle QOR, QOM is an exterior angle, that is angle 6. So if that is the case, same exterior angle is equal to sum of opposite interior angles. So we use the same concept. Angle 6 is equal to angle 4 plus angle 5. Again, OR and OQ are the radius of the same circle. And because these two sides of this triangle are equal, therefore 4 and 5 must be equal. So angle 4 is equal, OP is equal to OR is equal to R, radius of the circle. So angle opposite equal sides must be equal. Therefore, we can conclude that 4 is equal to 5. Angle 4 and angle 5 are equal. If angle 4 and 5 are equal, I can replace 5 with 4. So angle 6 is equal to angle 4 plus angle 4. So that means angle 6 becomes 2 times angle 4. Let this be your second equation. Now, when we were talking about central angle is POQ. POQ means angle 3 plus angle 6. Here we have got angle 3 as this in first case, angle 6 we have got in this second case. So let us add these two equations. Okay. The figure again drawn. Adding equation 1 and 2. Now I am adding this angle and this angle. That is angle 3 plus angle 6 is equal to 2 angle 1 plus 2 angle 2. This was the first condition. Angle 3 is equal to 2 angle 1 was the first condition. Angle 6 is equal to 2 angle 4 was the second condition. So we have added them together. Now you see here, both are having 2 as a common factor. Let us take out 2 as a common factor. 2 angle 1 plus angle 4. Angle 1 is here, angle 4 is here. So what has happened? Angle 1 plus angle 4 is angle PRQ, and angle 3 plus angle 4 is equal to POQ. So let us write this. So angle POQ, that is 3 plus 4, 3 plus 6, that is POQ, is equal to 1 plus 4, that is PRQ. PRQ. Clear? So this is the case 1 which we have proved. That is central angle is twice the inscribed angle. Now, we'll take the case 2. Case 2, what is the condition? PQ is a semicircle as shown in the figure. So I am again drawing the second case here. This is the figure now. Semicircle. Clear? Now, again, the same proof. So now since you have, so what you need to do is only learn the first case properly and learn to draw the figure correctly. The proof is exactly the same. You can just copy it once more. It'll come out exactly the same, and because why? Why it will be exactly the same? Because the numbering is in the same order. Extra angle 1, 2, 6 extra angle 4, 5. Clear? So that's why this becomes easy for your proof. Same thing now. Angle POR, this particular triangle. So 3 is an extra angle. So angle 3 must be equal to 1 plus 2. But OP is equal to OR is equal to R, radius of the circle. So angles opposite equal sides must be equal. So these two sides are equal. These two angles must be equal. So angle 1 is equal to 2. Replace angle 2 by 1. It becomes angle 3 is equal to angle 1 plus angle 1. Angle 3 is equal to 2 angle 1. This becomes a third condition. Now further. In triangle QOR, now we are taking QOR. In this side triangle, angle 6 is the exterior angle. When you say 6 is the exterior angle, that means exterior angle is equal to 4 plus 5. But OQ and OR both are equal to the radius. So angles opposite equal sides must be equal. Okay, angles opposite equal. So that means 4 and 5 must be equal. Draw the figure again. That means 4 and 5 must be equal. 4 and 5 is equal. That means angle 6 because angle 4 plus angle 4. Angle 6 because 2 angle 4. 2 times of angle 4. Let this be the fourth equation. Now adding 3 and 4. Angle third equation was angle 3 is equal to angle 2 angle 1 and angle 6 is 2 angle 4. So add those two. So angle 3 plus angle 6 is equal to angle 1 plus 2 angle 4. Take out 2 common. You will get 2 common. Angle 1 plus angle 4. Angle 1 plus angle 4 is PRQ and angle 3 plus 6 is POQ. So we get angle POQ is equal to 2 angle PRQ. So we have proved this for the case of a semicircle. Now we take the case 3. Okay. Case 3 is, which is a condition, PQ is a major arc now. Okay, we have already seen how the figure has been drawn. Now I'll just draw the figure directly. The figure, this is a figure. Now it's a major arc. It is more than half the circle. So it's a figure is drawn. Now what is it? Again, this is, if you take this triangle, again 3 is an exterior angle to this point triangle, that is POR. So same thing we are writing again. POR angle POM is the exterior angle, that is angle 3. So that means angle 3 is equal to angle 1 plus angle 2. But OP is equal to OR is equal to radius. So angle opposite equal sides are equal. So angle 1 is equal to angle 2. Angle 1 is equal to angle 2 means angle 3 is equal to angle 1 plus angle 1. That is angle 3 is equal to 2 angle 1. Let us call this as fifth condition. Clear? Now let us go to the next further part. Again the figure. Now I am taking this side triangle. What is it? ORQ. ORQ. And 6 is a extra angle. So in triangle QOR is an exterior. So QOM is an exterior angle. That is angle 6. So 6 is equal to 4 plus 5. Same thing written. But 4 is equal, OP is equal to R is equal to radius. So angle opposite equal sides are equal. That means angle 4 is equal to angle 5. That means angle 6 is equal to 4 plus 4. Angle 6 equal to angle 4. Let us call this as equation 6. Now let's add equation 5 and 6. Angle 3 plus angle 6 is equal to angle 2 angle 1 plus 2 angle 4. Take out common. 2 bracket angle 1 plus angle 4. 3 plus 6 is angle POQ. But POQ is more than 180 degrees. That's why we call it the reflex angle POQ is equal to 2 angle PRQ. Clear? This is so that means in every condition, whether it is a chord or a major arc or a minor arc or a semicircle, central angle is double the inscribed angle. So this condition could be written in different way as central angle is twice the inscribed angle. Or you can also write it in this form. Angle made by the arc or the chord at the center is equal to angle made by it in the alternate segment. Arc is here, alternate segment is this side. Clear? Hope you have understood. Please do subscribe for this so that you will get many more such videos. Clear?